Okay, student. Today we continue again to our lesson. There's a resolution of the force. So last time I give you the exercise, then you download, then after that you do it. So that means today I want to discuss about this kind of the question. Therefore, resolution of the forces, just a few questions only. Okay, let's try the question. Okay, first one, the question they show about the figure. The forces acting for the wheel for barrel. There's a being pushed by a farmer. Okay, so from here we're going to see the force. Okay, this one is the pushing force. Okay, the farmer will push the force up. Okay, they lift up. Okay, they lift up the mover, the barrel, wheel barrel, with the tension. There's a force T. We call it pushing force. There's a 480 Newton. Okay, with the angle is 30 degrees. Okay, the weight of the wheelbarrow, that's a 760 Newton. And the reaction force, okay, reaction force means the acting upwards. There's a 520 Newton. And one more last one is a frictional force. Okay, frictional force, they want to against the movement, okay, of the object. So this one will be labeled by R. Then the 390 Newton. So from this question, you need to resolving the forces T into the horizontal. That means they just want T only. Okay, for the horizontal component and also the vertical component. Then after that, you need to determine the resultant force on the wheel barrel. Okay, so that means when starting, we just resolve for the T. Then finally, we need to solve for the whole wheel barrel. Okay, so when starting, we're going to see this part. This one is a T, the pushing force by the farmer. So they go upwards. Then this one is 480 Newton. The angle is 30. So from this one with the angle forces, that means we can resolve by the two components. There's a horizontal and also vertical. Okay, let's see the resolution. Okay, first one, when I go up, okay, you can see two of the forces we cover with the tension. So that means you find it. This one should be the Fy, this one should be the Fx. Okay, now we go to label. Okay, want to see the triangle is more clear, so I bring the Fy go another side. Okay, so now you can see the perpendicular triangle become clear. Okay, now 30 degree is here, so you can see the blue color. This one should be the Fy. Fy is opposite the 30. Then another one, the horizontal one, is beside the 30. So from here, you need to differentiate which one using the cos, which one using the sine. Okay, come, let's see here. Okay, now become bigger, then we can do the calculation. Okay, this one should be the Fy, this one should be the Fx. So from here, we go to recall back. Okay, the line opposite the angle should be the sine. Okay, opposite the angle, so should be Fy lah. Another one is the line beside the angle, they call it cos. So that means now the effect we need to using cos. Okay, now we go to try to find horizontal and also vertical component. Okay, horizontal component, there's a Fx. So we're using 480. So that means the whole triangle, the longest one sure is a 480 Newton. Then beside the angle, then we're using cos. So should be cos 30. So after you press your calculator, we get it. That's a 415.69 Newton. Then you need to mention where they go. Go to the left hand side. Okay, so this one is a Fx. Okay, how about the Fy? Fy is a vertical component. So the vertical component, we're still using 480. After that, you need to convert become sine, because there's an opposite the angle. So from here, I can write the answer is 240 Newton. Then go to the upwards. So this one is a one vertical, one is a horizontal component. Okay, now we solve the component for the T already. And the last one, we need to solve about the resultant force. So the resultant force, that means you need to overall, you need to solve about the friction, you need to solve about the normal reaction. Okay, now we're going to see the overall diagram. Okay, so from here, the resultant force, there's a 25.69. Then they go to the left hand side. So finally, we just left one only. Okay, we don't have any horizontal. We don't have any vertical. We just got horizontal already. So from here, how to answer? We just write the resultant force is 25.69, then to the left. Okay, so from here, the question B, can you describe the motion of the wheelbarrow? Now the wheelbarrow already got the force, push, go to the left. So that means we know the wheelbarrow got move. So we just answer the wheelbarrow now with move with the acceleration, then to the left hand side. Okay, so we go to solve the number 1 question already. Okay, then we go to the second question. Okay, the second question now they show about the wooden block. Okay, the sliding down and the inclined plane with uniform velocity. Okay, the keyword is a uniform velocity. So means there's a balance force. Okay, now you need to sketch the free body. This one is a free body. The diagram for the wooden block. Use a symbol for the W for the weight of the wooden block. R is represent normal reaction, or you say the reaction force. And also the FR is a frictional force. So the first step we need to sketch. Okay, the weight is always go downwards, and also there's a straight line. We don't have any incline. So from here we find this straight line go downward. That one is a weight. Okay, now normal reaction, or you say the reaction force, they always is a 90 degree with the object, but they go upwards. Okay, so we go to show. Okay, so upward is a reaction force. They always acting upwards, and also 90 degree with the object. Okay, another one should be the friction. Friction is prevent the block to come down. So the friction must be parallel with the inclined plane and also go upwards. So from here we label this one as a R, then the weight is W. After that, the frictional force to be the FR. Okay, so this one is a 3 arrow to show prevent the box to come down. Okay, now we continue. It is given that the W is a 17 Newton. Okay, the block is a 17 Newton. By resolving the weight of the block W into the two perpendicular components, determine the R and also FR. So we show again the line. Okay, this one is a W. Okay, after that we got a perpendicular component, we got vertical and also horizontal. So now we draw the full line first. Okay, so from here you can see the weight. Now we need to resolve the weight with two components. One is a vertical, one is a horizontal. Okay, so from here the R we can extend, become longer. So after that we need to draw another line. This one is a WX. So if I bring the WX to come here, actually they can say about the FX lah, because now we're using W. Okay, we never using the F. So we label this one as a WX, this one is a WY. So if I bring the WX to come down, so that means they're just like one of the perpendicular triangle. Okay, why I want to bring the WX go up? Because I want to let you to see friction and also WX in opposite direction. So this one block already is uniform velocity, means the friction and WX should be equal. Okay, another one, uniform velocity is it. So the normal reaction, the R must equal to the WY. So that's why the object become balanced. So from here the question wants you to find what's the R, what's the FR. So that means they want to find, suppose it's a WY and also WX. Okay, now we go to solve it. Okay, FR. Okay, FR same like the WX. So I bring the WX to come here. You can see the WX just opposite 35 degree. So opposite we're using sine. Okay, so from here we just write W sine 35. Because the whole triangle, the longest one is a W. So W is how many? 17. So we bring the 17 is go in, then 17 sine 35. So from here we get it 9.75 Newton. Okay, that one is a WX. So that means WX is represented by the friction. So we just write friction is a 9.75 Newton. Okay, then we got the friction finished. Then we need to go is a normal reaction. So now R equal to the WY. So WY just beside the anchor, is it? So we just take W cos 35. So 17 cos 35, we get it. The answer is 13.93. So from here you can answer it. Now the R is a 13.93 Newton. Okay, so we go to solve already for the weight of the block. Okay, when it just divide become the WX and also WY. Actually, WX and WY, they also got another meaning. WY is a reaction, normal reaction, and also WX is a frictional force. Okay, then we go to the question number 3. Okay, question number 3, they're just pulling force applied from the iron pole. Okay, now you can see the iron pole, they pull by two forces. One is a 160 Newton, another one is a 200 Newton. Okay, with angle how many? For the 160 Newton, there's a 35 degrees. For the 200 Newton, there's a 70 degrees. So you need to resolve every pulling force into two perpendicular components. Okay, now we got two forces. 160 you need to resolve. 200 you also need to resolve. Okay, now we go to draw the simple part, how to resolve first. Okay, first one, we draw the Fy. Okay, so from the 35 degree with 160 Newton, we can resolve by the Fy. The Fy is go upwards. Okay, then another one is 200 Newton also can be resolved, the Fy. Fy also go opposite direction, that's a downwards. Okay, so you can see one is upwards, another one should be the downwards. Okay, then we go to the next part. Okay, vertical, 35 degree with 160 Newton, they can resolve become the Fx. This one Fx is horizontal, go to the left hand side. So another one also go to the left hand side, there is a 200 Newton, 70 degrees. Okay, so later we see which one should be the bigger. So now you can see two arrows should be the same, so that means later we need to plus together because they are the same direction. Then you can see the Fy. Fy is opposite direction, so later we need to minus. Okay, now we go to write out the equation first. Okay, this one is a 160 cos 35 because they just beside the anchor. Then the bottom one also same, they beside the anchor, so 200 cos 70. Okay, Fy sure using sine because they're opposite. So from here, the first one, there's a label 160 sine 35. Another one is 200 sine 70. Okay, so now we need to do the calculation. Then finally, we need to know, okay, you left which one. Okay, then we go to solve already. This one is finished to draw already. Okay, then we go to calculate the resultant force acting to the iron pole. Okay, now we need to plus and minus. Okay, we do the one by one. Okay, this one 160 cos 35 is a 131.06. Okay, then we do the calculation first. 200 is a 68.40 Newton. Okay, this one is a 91.77 Newton. And the last one, 200. Okay, this one is a 187.94. So normally we take the biggest, okay, biggest number to minus the smaller numbers. Then we follow the biggest direction. Okay, so now you can see the Fx. Fx is the same direction, so we just plus. Okay, we just know the horizontal must go to the left hand side. Okay, how about the vertical? Vertical, you can see this one is a 107.94. So this one should be the bigger lah. So after we minus, we follow the direction, go downwards. Okay, now we continue. This just now the calculation. Okay, now I need to redraw the final forces. Okay, final forces horizontal plus together become 199.46 Newton. Okay, for the vertical, we minus. Okay, after minus, I left 96.17 Newton, go to downwards. Okay, now from here, we can find the resultant force by using theorem by Hercules, because now you create one of the perpendicular triangle. Okay, now we're going to see the resultant force. Okay, this one is a resultant force. They come from the original point, then they come out. Okay, two of the vertical component and also horizontal component, they cover the resultant force. Okay, now we go to solve it. Because this one is a resultant force, you need to mention about the angle, is it? So we solve the angle first. Okay, I want to find this angle. Okay, tangent data. This one is a data. 96.17. Okay, I bring the fy to come here. Okay, I bring the fy to vertical part, create one triangle. So this was a 96.17 over 99.446. So opposite over adjacent. So there's a tangent. So I find it. The data is 25.74. So the data should be here. Okay, this one is a 25.74 degrees. Okay, now we need to find what's the f. Okay, by using theorem. Okay, theorem, so that means you need to take 199.46, you go to square, plus 96.17 square. After you plus together, then you need to square root. Okay, after square root, we find it 221.43 Newton. Okay, this one just magnitude. Then you need to measure with 25.74 degree. Beside where? Beside the horizontal component. So that means now your resultant force is 221.43. Then the angle is 25.74 beside this horizontal component. So that means now more specific to explain where is the location of the resultant force. Okay, so this one is important. When you just mention resultant force, we need to say where's the location, then we find the angle. Okay, then we continue. Okay, now they need you to draw the parallelogram diagram. Okay, so from here we need to use a scale is 1 cm represented by 20 Newton. Okay, this one is a 160 Newton, you divide by 20, so we're using X cm. So another one divide by 20, this one we're using 10 cm. So you need to draw, okay, exactly to draw. Then you need to measure using your protractor. You need to measure the angle is exactly 35 and also 70. Okay, now, okay, this one is a drawing. Okay, exactly you go and draw. Draw this one is a X cm. Then you measure this one is 35 degree. Then you measure this one 70 degree. Then you draw for 10 cm. After that, you join back, become one parallelogram diagram. And the last part, you go and draw your resultant force. Then you need to measure this one. F is how long. Okay, after you measure how long, you need to multiply again for 20 Newton. So that one is your final answer. Okay, now we go to check. Okay, the length of the diagonal we measure, that's 11 cm. So 11 cm, I go to multiply for 20. I get it 220 Newton. Okay, 220 Newton. Okay, if we check back just now answer. Okay, just now answer is 221.43. This one is for calculation. So that means calculation, we can count more detail. Okay, can count until 2 decimal point. But for drawing, we cannot. Drawing exactly, there's a round number. So that means for drawing, we can get it just now, there's a 220 Newton only. So that means if you're using the two method, actually the answer almost the same. Just the calculation is more detailed. Okay, this one just we can count the round number only. Okay, so from here, this one just a discussion for the last time for the exercise. So what you need to do for the next exercise, there's a revision exercise. So you need to copy this one website. Okay, after that you need to download. After that you need to print out. Then you see inside got a little bit exercise about the resolution. So you need to solve it. Okay, so from here, this one is your homework lah. So please finish it. Then after that you keep it inside your file. Okay, so from here our lesson just until this part. So hopefully you understand what I explained about the 3 questions for the resolution forces. Okay, they're just a simple question only. So the following that means there are also some of the question that's easier, a little bit hard, so you need to try by yourself first. Okay, so our lesson just until here only. So thank you for your watching lah. So important, you need to do some revision. Okay, so our lesson just until here. So thank you for your watching. Okay, see you for the next lesson. Okay, bye.